Now, we know one application of confidence intervals is to estimate the interval um, that gives us the range of values we think the parameter could be. But there's actually two other very important applications of confidence intervals. And the first is that a confidence interval lets us also perform hypothesis tests. And this is kind of important because when you're a student, and I was the same way when I was a student, most students, they think that hypothesis testing is the be all and end all. And it's a very important part of statistics, there's no doubt. But the reality is that the confidence interval actually gives you more information than a hypothesis test. It gives you a point estimate for your parameter, it gives you an interval estimate for the parameter, and it also lets you run a hypothesis test. And here's how this works. So let's suppose, and I'm not going to worry about this. This is an arg. If we had time in class, I'd show you where the statement comes from. Let's go back to the example with Abe that we talked about before. So we said that Abe had a, if I remember correctly, it was a 95% confidence interval for mu, where mu was the average amount of revenue his restaurant bought in a day, and the confidence interval, and let me write 95% confidence interval. Yeah, so it's 3,550 to 3,802, if I remember correctly. So it looks like this. And so his average must have been, his actual sample mean would have been here. We could take the average of these two, right? So if we went ahead, we could just do this really quick, right? 3,350, 25373. So we'd end up getting 3,750 and 150 and 26. So we'd have 6 to 3,920. So this was his mu hat. And this was his confidence interval. So what he's saying is that he's that that if he had to estimate the range of values the parameter mu could have, he would say it's between 3,550 to 3,802. Now let's suppose he wanted to run a hypothesis test. You can run a two-tailed hypothesis test at alpha equal to 5%. So what I'm going to do, I'm going to take the confidence level and subtract it from 100%. So alpha would be 5%. In other words, the significance level and the confidence level have to add up to 100%. And let's run a two-tailed test. For any value of mu. Okay? So suppose, for example, Abe wanted to test, suppose his null was that the population mean was $3,600. Remember, two-tailed means the alternative has to be not equal to. What would he decide at a significance level of 5%? The way that we run the hypothesis test is we check to see if the value that we're testing is in our confidence interval. So notice that 3,600 is in our confidence level. So based on this confidence interval, we would fail to reject the null, because the value that we're testing is inside the confidence interval. Let's suppose, on the other hand, Abe wanted to test and see if mu is equal to 3,900. So now let's suppose he wanted to run. So notice I can run an infinite number of hypothesis tests. Whoops. So now suppose Abe wanted to run the hypothesis test again at 5% for a two-tailed test, but now he uses the null as population mean is 3,900. And again, the alternative is that it's not. What would he decide using the confidence interval? Well, let's look at our value 3,900. It's up here. It's outside the confidence interval. So he would reject the null. And so the confidence interval actually lets us run an infinite number of hypothesis tests, which is really kind of clever. So here's how it works. If the value we're testing, I'm just going to call that mu sub star, okay, is within the confidence interval, then we're going to fail to reject the null. And when you think about it, it kind of makes sense. Why does it make sense? Well, this is the range of values that we think mu can have. Okay? So if we pick a value in that range, we should fail to reject that. It couldn't be that value. That couldn't be the true value of mu. On the other hand, if our value is outside the confidence interval, so we compute a confidence interval and our value's outside the confidence interval, we're going to reject the null. And of course, this isn't just for mu. It also works for pi. It's exactly the same way. Okay. So this is a kind of useful thing, all right? The fact that a confidence interval lets us perform two-tailed hypothesis tests if we use a significance level that's 100% minus the confidence level. Now, there is another very important use of confidence intervals, which is it gives us best case and worst case scenarios. So notice that, for example, when you're computing the confidence interval for mu, okay, we have a lower limit and we have an upper limit. So this upper limit is an estimate as to the largest that mu could be. And this is an estimate for the lowest mu could be. And so this lets us do kind of like a best case and a worst case scenario. And let's just kind of look at Abe here, okay? Let's look at this example with Abe again, all right? So first, let's think about this confidence interval. We just had running hypothesis tests. We just did that a second ago, right? So this is our, again, this is all this information we talked about before, 95% confidence interval for mu. This is our confidence interval. And based on this confidence interval, he wants to run hypothesis tests. So if he ran a hypothesis test that mu is equal to 4,000, what would he decide? Well, notice 4,000 is outside of our confidence interval. So what would we do? We would reject the null, right? If on the other hand he wanted to run a hypothesis test to see if mu is equal to 3,400, again notice it's outside the confidence interval, right? So 3,400 is outside the confidence interval, so again he would reject the null. If he wanted to run a hypothesis test to see if mu is equal to 3,600, well, 3,600 is in the confidence interval. So he would fail to reject the null. And if he wanted to run a hypothesis test to see if mu is equal to 3,800, exactly the same thing. 3,800 is in our confidence interval. In our confidence interval, so again he would fail to reject. Okay. Now I want to do this best and worst case scenario calculation. So here's kind of the idea. Suppose Abe is writing a budget, and Abe wants to kind of estimate what his total revenue will be for next month. Okay? So notice that the best case scenario says that mu is going to be 3,802. And so if he wanted to compute the maximum expected revenue over 1 month, he'd take mu times 30. So the max revenue that he would expect would be 30 times 3,802, right? And we could just work that out in our heads, right? So that's going to be 0, 6, hold on a second, sorry. Okay, so that's going to be 0, 6, 0, 23. So this would say that he would expect the most revenue he would take in next month would be around $234,060. That would be his max expected revenue, just multiplying those out. Oh, I'm sorry, my bad. I thought that looked a little too large. Sorry, 1, yeah. So $114,060. Okay. What if, on the other hand, he wants to see, well, what would be the minimum he'd be bringing in? Well, what is his estimate for the minimum? Well, his estimate for the minimum value that mu could have would be 3,550. So the minimum revenue would be 30 times 3,550. And again, you just work out whatever this is, right? And it's $106,500. Okay. So people do this sort of stuff a lot. They use confidence intervals. They use the average to compute the total amount of a variable over a period of time. Okay, and this is a kind of a classic example of how they use the confidence interval to get the best case scenario, and also the worst case scenario. This is a very common use of confidence intervals. All right, that looks good. That's pretty much all for confidence intervals. So, you want to work the problems, go back and watch the videos. If you get stuck, again, I have office hours. Greg has SIs. There's more than enough opportunity for you to get help.